Find two quadratic functions, one that opens up and one that opens down, whose graphs have the given x-intercepts. So I actually want us to play around with some fractions in this example, so please change your paper to say 1/4 and 1/8. So if I use factored form, since I have my x-intercepts, it would be a times x minus 1/4, x minus 1/8, which is just not a pretty sight with these fractions. So let's see how to clear fractions when we have fraction zeros. So we know that x equals 1/4 and x equals 1/8 are our x-intercepts, or zeros. So that means we set an equation equal to 0 to solve for these x's. Well, let's get this equation equal to 0. The first thing we need to do is multiply by 4. 4x equals 1. Then we need to subtract 1. And I have 4x minus 1 equals 0. Here, multiply by 8. 8x equals 1. And then subtract 1. 8x minus 1 equals 0. So keep in mind, this all came from solving an equation where we used the zero product property. So now, this connects us back up to our factored form. F of x equals a 4x squared, or 4x minus 1, 8x minus 1. So I'm going to put this into standard form. F of x equals a 32x squared minus 12x plus 1. From here, we want to create two equations. One that opens upward. Well, if that's the case, a must be greater than 0. So I'm going to let a equal 2. I'm just picking a positive number. So f of x equals 64x squared minus 24x plus 2. Next, we need one that opens down. And if that's the case, a must be less than 0, so it reflects across the x-axis. So I'm just going to let a equal -1. If that's the case, f of x equals negative 32x squared plus 12x minus 1. So answers may vary, but what's more important is being able to manipulate from zeros or x-intercepts to your function.